Welcome to lesson 11 on ratios. We use ratios for comparisons. It's an important topic, and there's a lot here, but you've probably seen a lot of it before, so I wouldn't be intimidated by it. So here's a little example from the book on Objective 1. It says statistics without comparisons, such as, and here's an example, there was 32,367 motor vehicle deaths in 2011. Just that statistic lacks meaning. It begs the question, is this a lot? Often, we want to track change over time. So if there was 43,512 motor vehicle deaths in 2005 and 32,000 in 2011, that's 25% less in the 2005 statistic. Seems to be significant, but maybe there was fewer people in 2011 than in 2005. Or maybe there was fewer vehicles. Or maybe people drove fewer miles. So to make meaningful comparisons, we really need ratios. It's the most basic form of a relationship, simply comparing the relative size of two quantities. So let's take another look at another example. This is the oft mentioned in the newspapers Coronavirus Resource Center from Johns Hopkins. And it lists all the countries and how many confirmed cases they have. You can see, and this was taken on June 18th, there were 8.4 million cases in the world. Well, let's take a little closer look at three countries. The United States, right here, which has over 2 million confirmed cases. India, which has 366,000 confirmed cases, almost 367, and the United Kingdom, which has 301. Now, how about if I ask a question? Which country do you think is doing the best job at controlling the virus? Now, you might be tempted to say the United States is doing terrible. They have 2 million cases, whereas India has 367,000, and the United Kingdom has 301. So maybe the United States is doing the worst, India is doing the second worst, and the United Kingdom is doing the best of the three of those countries. But what important information am I lacking here? Actually, I'm lacking a lot of important information, but one main thing. Think about it. Well, one very important factor is the population of each country. So here's the countries we're talking about, here's their confirmed cases, and here's the populations. Notice the population of India is 1.3 billion. In fact, in a couple of years, India will have the largest population in the world. They will surpass China, which has about 1.4 billion right now. The United States is actually the third most populated country in the world. And the United Kingdom has 67 plus million people. So we have our confirmed cases and our population, and I'm going to look at cases per 100,000. So I'm thinking that may give us a better insight into how many cases there are in the population. And you might ask, how am I going to find these cases per 100,000? And if you recall back to basically equivalent fractions, that's all the math you need to know. Boom. So do the United States. That many confirmed cases out of that much population, I'm going to change the ratio. This is now a rate, right? I'm going to change the rate so I have 100,000 on the bottom. And how do you do that? Well, you cross multiply and then you divide. And so for the United States, there's 653.5 cases, confirmed cases per every 100,000 people in the population. Okay, so now we have rates. I filled the other ones in per 100,000. And it looks like India has by far the lowest amount of confirmed cases per 100,000. Only 27.7 people have or had COVID out of 100,000 people. And by the way, you're allowed to use decimals in a ratio. Obviously, a half a person can't get the virus. Well, that particular ratio has only given us so much information. If we look at the United States, for example, and look over here on the right, this is daily cases. You can see that the United States reached a peak and has slowly been coming down. The United Kingdom kind of reached a peak at about 5,000 or 6,000 and has quite more rapidly been coming down than the United States. And now let's look at India. India, over here on the bottom right, has been increasing in cases quite dramatically in the last month. So you expect those numbers in India to go up. However, they got a long way to go to catch the United States. But here's another problem. How much testing do you think they're doing in India? It's a developing country without a lot of resources, so they're probably not testing very many people. They're probably testing only people that are very, very sick, even if then, because it's lots of areas of poverty. So they're not really even doing the testing. So that's a confounding variable. We don't know how many tests are given. So this Johns Hopkins site is useful, but it's giving you a snapshot, and it's very difficult to draw conclusions because of all the information that is really just lacking. But ratios are a great way to begin the exploration of data. So a understanding of ratios requires a review and an understanding of basic ideas and fractions. I circled those three numbers in red. What's the relationship between them? Hopefully said, well, they are all equal to 1, therefore they are all equal to each other. And that would be correct. Now here's one, 7 divided by 1. Which is a fundamental idea that any number divided by 1 is itself, right? This idea is any number divided by itself is 1 except for 0. So this one's going to be 1,000. This one here, if you said 1, you would be correct. And this is really important when you're dealing with ratios. A lot of times you'll just get one number, but it's really over 1. Because a ratio, the bottom number, the denominator never goes away. And here's another important concept. Any number times 1 is itself. You get that? 7 divided by 1 is 7. 7 times 1 is 7. And here's a really important one right here. Any number times 1 is itself again, right? It doesn't matter if it's a fraction or whatever. Oh, this might seem hard. You want to take your calculator out. But look what you're doing. Look at this number. That number is 1. 8 times 1 is 8. And how do you, this one here too. This is 2/5. You can make it into 4/10 by multiplying the numerators and multiplying the denominators, but it doesn't change the fact that it's also 2/5. 2/5 and 4/10 are equivalent. And this one here, 3/4 times 1 is 3/4. You could multiply the numerators and then multiply the denominators and get 9/12. However, 3/4 and 9/12 are the same number. So let me just pause for a minute and go back to another problem we're just looking at. So this is the problem we looked at with confirmed cases of COVID in the United States, population of the United States. And we changed it in and we found the value of X is 653.5. I just want you to realize this. This ratio here is the same as this ratio here. In the same way, 50% is equal to 1/2. So these are the same equivalent numbers. It's like equivalent fractions. Remember that? 1/2 is the same as 2/4 is the same as 4/8, etc., etc., etc. There's a million ways to rewrite this ratio with another equivalent ratio. So to take a look at fractions once again, because they're so related to ratios in terms of how we solve for these things. I'm going to pull out a yellow pen here, a little thicker. So I'm going to change 3/4. Remember from 5th grade, how do I change one fraction into another fraction that's equivalent? Well, you only have one choice, and that is to multiply it by 1. That's your only choice. If I can keep my multiplication sign there. Now, the only choice that you have in terms of 1 is what form of 1 are you going to use? Obviously, I can't. 3/4 times 1 is 3/4, but I want to change it into 12ths. So, what am I going to do? And if you answer that you're going to multiply it by 3/3, you would be correct, right? Because 4 times 3 is 12 and 3 times 3 is 9. So what I always ask my students at this point is, what is the relationship between this number and this number? Which one's bigger? And if you said that they're equal, you're right on the money. Because I took a number and I multiplied it by 1. And got a new number, which is equivalent. That's what the equal sign means. Now, the other way of doing this, which we use when things are not so pretty, like 4 times 3 is 12. But the other technique we use is we cross multiply and we get 4x equals 36. And then we divide. We divide this side by 4 because 4 divided by 4 is 1. And 1 times x is x. And we get the same answer. This is the technique, cross multiplying and dividing, that we're going to use in these coming sections. All right, so let's look at problem 1, and we want to write 2 to 5, which we could write 3 different ways. We could write 2 to 5. We can write it 2 to 5. Or we could also write it 2 to 5. There's 3 different ways of writing it, and they all mean the same thing. The other thing I could do is write it as, how about this, 4 to 10. Think about what I did. Right? I took this fraction, I multiplied it by 2/2, which is 1, because 2 divided by 2 is 1, and I got 4/10. So there's another ratio that's equivalent to it. If A to B is 3 to 1, write this ratio 4 different ways. Well, I can go 3 to 1, I can go 3 to 1, or I can go 3 to 1. There's 3 ways of writing it. Now, if I multiply this by, say, 4/4, you multiply straight across, right? I can come up with a new equivalent fraction of 12/4. So there's some ways of writing that one. So this one I can write in different ways. It's 3 to 6. So I could write 3 6. I can write 3:6, or I can write 3 fraction bar 6. So there's 3 ways. You might notice that I can reduce this, hopefully understand that, and that would be 1/2. So there's a 4th way. And I can also take either one of these, because they're equivalent, and multiply it, say, by 5. So I'll multiply this one by 5 over 5. Not multiplying by 5, I'm multiplying by 1, and I get 5/10. So 3/6, 1/2, and 5/10 are all the same number. I can write this ratio as a fraction in a million equivalent forms. I can go 6/12, I can go 7/14, I can go on forever. Finally, I have this fraction here. 3 feet, and I better move that up a little bit, put it over here. 3 feet to 39 inches. Can I reduce that? I want you to think about that. Well, if I divide both sides by 3, I'm going to get 1 foot to, how many is that? 13 inches. And that's the same ratio. These ratios are the same. Okay, number 5. It says, if the number of cats to total animals is 3 to 10, express this as a fraction. Can we also express this as a decimal and a percent? Well, let's take a look at that. Okay, well, as a fraction, that should be pretty easy, right? We're just taking 3 over 10. And you might want to put the units in what these things are so you don't lose track. So that's 3 cats to 10 total animals. I do this because it's important to keep track of what things are. As a decimal, you just divide it, right? So there's your decimal. And as a percentage, if you recognize 0.3 is the same thing as 0.3 over 1, which I also should put here, and a percentage is a part per 100, I can change this by multiplying it by 100 over 100, which is 1. And that would move the decimal 2 places. And I would get 30%. Some students think you just move the decimal 2 places, and you can do that if you recognize you're also doing the same thing to the denominator. You're just moving, notice this is a 1 with 2 zeros, a percent sign. You're moving that up here. So now we're going to write these, each of them, in sentences. So for the first one, we can say there are, per every 3 cats, there are 10 total animals. For the second one, for the decimal, we can say there are 0.3 cats for every 1 animal. And on the third one, we can say there's 30 cats per every 100 total animals, or that cats represent 30% of the total animals. So, number 6 in your workbook. If the number of cats is 3 to 6, express this as a fraction. Can we also express it as a decimal and a percent? Well, sure. And I'm gonna write out the units because without the units, you lose track really quick. And that would be just dividing it. You would get 0.5 cats to one dog, or multiply the numerator and the denominator by 100, and you would get 50 cats for every 100 dogs. And I'm going to actually write this is 50, and I could say it's 50%, but it's really tricky to use this in a sentence. And the reason being is that it's a part-to-part ratio. In number 5, we had cats to total animals. That was part to total, part to whole. This one is part to part. But we can make a statement using 50%. And what we would say is that the number of cats is 50% the number of dogs. Now let's just review this. Well, it's not a review, but let's go over what would be part to part and part to whole. And you kind of decide and I'll move them. But what about 18 to 64-year-olds compared to 65-plus-year-olds? Is that part to part or part to whole? Well, if you guessed it's part to part, you're correct. What about food cost to your monthly budget? So your food cost to your monthly budget. Is that part to part or part to whole? Hopefully you guessed that one correct. Now the first one we did, cats to total animals, that's part to whole. But the one we just did, cats to dogs, that's part to part. And it's good to know the difference between the two. Okay, we're just gonna go over rates just for a second. They're just a special kind of ratio that allows us to make comparison using the word per. And rates are between two completely different things. So I'm going to throw up a couple here for you. Dogs to cats. That is a ratio because dogs and cats are both animals. 18 to 64-year-olds to 65-plus-year-olds. That is a ratio because they are both people. Miles per hour. That is a rate because they are totally separate things. There's no relationship between miles and hours. So that's just the background. Proportions are when you have two different ratios that are equivalent. You know this, again, from fractions. Equivalent fractions are proportions. You can make up proportions that are equivalent. Like, for instance, this one. 3 apples to 4 oranges. I'm going to put A here for apples, and I better not put O, but I'll put a small O for oranges. We know that. I'm going to set up a proportion and solve this. So there's the first ratio. There's the equal sign. And the second ratio, I only have half of it. I have 6 apples. Now here's where you got to be really careful. The 6 goes on top because it's apples to oranges, apples to oranges. Apples to oranges, apples to oranges. If you flip this, it's a complete disaster. I call it KOD, the kiss of death. So don't do it. So then this one here, we don't have to cross multiply and divide. We can just take 3/4 and recognize that 3 times 2 is 6. So we're going to multiply by 1 in the form of 2 over 2. And the way you multiply fractions, you multiply the numerators, multiply the denominators straight across, and the answer is 8 oranges. So here we're going to solve two equations using what I call our fundamental technique of cross multiply and divide. So what I am going to do is cross multiply that one and that one. So over here I get 4 times x equals 3 times 12, which is 36. And divide both sides by 4. The reason I divide by 4, not 36, is because over here, 4 divided by 4 becomes 1. And 1 times x, which is just a number, is x. So for this one, I get x is 9. Over here, cross multiplied, I get 2x equals 2268. Divide both sides by 2, and I get x equals 1134. So this is a fundamental technique, setting up a proportion and solving it this way. Okay, so here we're going to number 9, we're going to look at motor vehicle deaths. And we have all these different categories of things, like for instance, we have the year, we have the number of people killed in motor vehicle deaths, we have the population. Notice the population says in thousands. Well, that means that these are not the actual numbers of people in the United States, because it's in thousands, so you'd have to take that number and multiply it by 1,000, or 10 to the third, which means 10 to the third would, or 1,000 means move the decimal 3 places. Here is the fatality rate. This is the ratio per 100,000 in the population. This is the number of licensed drivers in the thousands. Again, add 3 zeros to these numbers. This is the fatality rate per 1,000 licensed drivers. So this is a ratio. This is the number of motor vehicles registered, again, in the thousands. So you'd have to add 3 zeros. And this would be a ratio of the fatality rate per 1,000 registered vehicles. This is the vehicles miles traveled. And this is in billions. So that's not the total amount of vehicle miles traveled. That is, to make this the actual number, you'd have to multiply it by 10 to the 9th power, or you'd have to add 9 zeros to that number. You should kind of know this one. It's 10 to the third, multiply by 1,000, add 3 zeros. 10 to the 6th is a millions, multiply by 10 to the 6th, you'd be adding 6 zeros. And 10 to the 9th is billions. If you multiply by this, you would add 9 zeros to these. And finally, the fatality rate per 100 million vehicle miles traveled. So they're looking at motor vehicle deaths in many different ways. The first one here, A, it says write a ratio comparing motor vehicle deaths in 2011 to the total population in 2011. Notice the word total population. So 2011 be right here. I would have this many deaths, and I would have this many people times 8,000. So I'm just going to write the ratio. Give it some thought before I put it up. So notice I added the 3 zeros down here. So there's our ratio of motor vehicle deaths to the total population. These are actual numbers. These are the actual number of motor vehicle deaths, and that is the actual number of people. Okay, the next question, they want you to explain how the table came up with 10.39. Well, here is our 10.39. Maybe I should make it a different color. 10.39 is right here. And that category is fatalities per 100,000 in the population. Well, we're looking at the year 2011, and we have this information here in our ratio. So basically, they're asking you to change the bottom number, rescale this ratio to some number over 100,000. And my guess is that number is going to be 10.39. But let's just check the math first. Okay, so we'll use our fundamental technique. Cross multiply and divide. I'll put this on pause, give you a chance to do the problem. So cross multiplication and divide by 311 million. And we get x is 10.39. Now put that 10.39 in a sentence. And what you would say that there was 10.39 motor vehicle deaths for every 100,000 people in the population. So our next question is, can we write this, which means the 10.39, can we write that as a percent and use it in a sentence? I want you to think about that and see if you can come up with the correct proportion in order to accomplish this. So here is our percentage that we just got, 0.01039 over 100. Now this is why I put the units in, because we're trying to write a sentence using this. And it's a percentage, right? Anything over 100 is a percentage. It's just a ratio per 100. Putting in the units, I think, really helps you to begin to get your mind around how to write a sentence. So think about how to write that sentence, and I'll put it up. So here are the three ratios that we've been dealing with. The first ratio is hard to compare to other years. The ratio over 100 is almost unintelligible. I mean, what does 0.0139 people mean? Whereas the one in the middle is easiest to understand and compare to other years. So basically, we scale ratios to a useful number in order to assure communication. That's the whole idea. We could scale these to any bottom number we wanted. But the per 100,000 in this case is the best. Okay, from your workbook, number B, write a ratio comparing motor vehicle deaths in 2011 to the number of motor vehicles in 2011. So 2011 is the last year, and we're going to compare motor vehicle deaths to registered motor vehicles. So there's going to be our ratio. And then it's asking us, how did they get this number? Okay. Now, why, you might ask why. We already kind of looked at this. We did this analysis on this column here, which was fatalities per 100,000 in the population. Why do they have more information here? Why don't we just look at this? Isn't this enough? And the answer is no, because what if over the years the fatality rate per 100,000 has been dropping, but what if over the years less and less people are buying cars and more people are biking or living close, they could walk to work or whatever. So that's why they now analyze this one here. So this is the kind of the column now that they're analyzing based on number of deaths per number of vehicles, which is right here. Okay, so we're going to make our ratio of motor vehicle deaths, which is right here, to total motor vehicles registered. Don't forget I'm going to add 3 zeros to that because it's in thousands. So there I have my motor vehicle deaths per how many motor vehicles there are registered. And I want a new ratio, so I'm going to form a proportion here to find out how many motor vehicle deaths there were per 100,000 motor vehicles. And you should know what I'm going to get because it's right here. I should get 12.57. But let's quickly do it. So there is using our fundamental technique, cross multiplying and dividing, and I get 12.57 as we realized, and now I'm going to just put that in a sentence. And the sentence is, there is 12.57 motor vehicle deaths for every 100,000 registered vehicles in 2011. So we're going to use this chart for 9 and 10. And just going over it, here are different types of college institutions. Here is tuition and fees, and then room and board, and finally total charges. So you want to make sure you read this carefully, right? So it said for the years 2013, 2014, which would be this here, compute the ratio of private four-year tuition and fees, which is going to be this, to public four-year in-state tuition and fees. So here's the public four-year in-state tuition and fees. And there's two privates, but I'm going to use the nonprofit here. Doesn't say exactly, but there's not enough data here. So there's the ratio, and put it up over here. So there's my ratio, and now I want to scale the second quantity, which is the bottom number, to 1. You think about how I'm going to do that. And if you guess set up a proportion, you would be correct. There it is. Now I'm not going to cross multiply and divide. I'll let you do that, but I will put up the answer. But when you're rescaling something, that's what you do. We've done it a lot of times now. And for this one, I'm getting x equals 3.38. Of course, it's all dollars. Now write that in a sentence. You write it in a sentence. For every $3.38 you spend at a private four-year nonprofit institution, you can expect to spend $1 at a public 4-year in-state institution. Or you can flip it. For every $1 you spend in a public 4-year in-state, you can expect to spend $3.38 at a private 4-year. Okay, for B here, we have our original ratio. You want to scale the first quantity to 100. So think about that. I want the same ratio, except I want the top number scaled to 100. That means I don't know what the bottom number is. But it's the same process. Cross multiply and divide. And the answer is 29.55. And now write that in a sentence, and I'll put the sentence up. Okay, in this one we want to scale the second quantity to 100, which means we want another ratio that's equal to that ratio, but with the bottom number scaled to 100. And then write a sentence. The answer is, and I'm getting 338.40. And I'll put that in a sentence. And I'll put the sentence up. So here's D. Can we write any of the above as a percent? Well, the one we just did is written as a percent. And I got a news flash for you. Any ratio per 100 is written as a percent. A percent is just simply means something per 100. Now, how would I describe this in a sentence? Well, how would you describe this? I would probably say the top number is equal to the bottom number. How about this? I'm going to say the top number is twice as big as the bottom number. How about this? Well, I'm going to say that it's about 3.5 times bigger and write it as the following. So now we're going to compare tuition and fees for a public 2-year, which is right here, to a private 4-year, which we're using this one. So remember, the top number is public 2-year, and the bottom number is private 4-year. So they want to represent the ratio in two different ways, one of which is scaled to 1 or 100. Well, in order to even begin, I've got to start with the ratio that I know is true, which is this one, which I'll put up. So there's my ratio. In order to find another ratio, I'm going to have to set up a proportion. And I'm looking ahead at B, and it's talking about percentages. So I'm going to do this one over 100. And now hopefully you know how to do this now. Cross multiply and divide, and you will get. So we have, there's our two ratios, right? And they are equivalent. And here's the one that is per 100, which is a percentage. It's a little difficult and tricky to use it in a sentence. But you can say, and this is just for tuition and fees, which I'll leave out, and for the year, which I'll leave out, but you could say that public 2 years costs 10.85% that of private 4 years. Well, I decided to show up here just for the last question, thankfully, right? and cheer you on. And this really could take no, I'm not going to take a half an hour. There's a easy and laborious way of doing this, and then there is a difficult and fast way of doing this. So I'm going to show you the laborious way first, all right? So these are the empty boxes that we need to put numbers in. Now let's say we're going to put a number here first, right here, X. So I have the ratio between private tuition and public four-year tuition in state. There's the ratio, and I want another ratio with public four-year tuition scaled to 1. Right, so that's what I'm doing, and I'm going to put it up. So I put it in both ways. I'm using just the top row, right? There's the ratios are all there. This to this, this to this, whatever. So, and being I'm trying to find X here, you can do public four-year to private, public four-year to private, or you can do private to public four-year, private to public four-year. If you're shrewd, you can just divide this and get the answer. Otherwise, you got to cross multiply and divide. And the answer is 340. And so these ratios are going to be the same. Right. But I can just now I can go ahead there if I want it and make that 340. Okay, now let's say we want to find this. The ratio is going to be something to 1. So I'm dealing with these two numbers, and I'm dealing with these two numbers. The known ratio is here. I'm always going to go back to the known ratio because rounding, for one thing. I mean, so I can set up a ratio, and here the other ratio, and I've got a proportion here. See if you can set that up, and I'm going to put it down here. Now you can go either way. I'm only going to go one way. See if you can set that up. Okay, so I'm solving for X here, and here is the known ratio and the one I'm looking for. So I created a proportion. You could cross multiply and divide, but if you're smart, you could just divide these two because you're going to get a decimal, and a decimal over 1 is the same thing, correct? So I'm getting X equals 0.37. And that would go right where that X is there. 0.37. So, where did the 7 go? So it's the same. You could say now that for every, and then you can make statements about this stuff. If you get this to $1, you can say, well, it's 3.4 times more expensive to go to a private school. Or you could say it this way. You could say for every $1 you spend in a public four-year state school, you would spend 37 cents in tuition and fees in a public two-year. Okay, I'm back. Now this is a much cooler way of doing that ratio table. I'm going to do this problem, but the logic is exactly the same. Okay, so I'm going to multiply this by the number 1 to get this. Now, 1 comes in millions of forms, correct? And I'm not going to use this form. But I can't use like 3 over 3 or 4 over 4, right? So what am I going to do? How about if I take 18 and divide it by 5? What do you get? Well, I get 3.6. Now that means from the fact families, 5 times 3.6 is 18. So I found this number here, 3.6. And now I'm going to put on the top 3.6. And 3 times 3.6 is 10.8. So 3/5 is the same thing, same number as 10.8 over 18. Now watch how cool this is, how it works on that ratio table. So I'm going to start off showing you how we got this number here, which is 3.4, using this method. So I have 8893 and it's going down to 1. So what would I divide it by in order to get 1? And the answer is pretty obvious, hopefully. 8893. Well, if I divided this by 8893, I can divide 30,094 by 8893. What do you think I'm going to get? And hopefully you said 3.4. Isn't that amazing? How about if I take now 3264 and divide it by 8893? What do you think I'm going to get? You're right. Yep. 0.37. Okay, so let's look at this one. To go from here to here, I'm going to find the number that when I multiply this by, I get 100. And over here, then I'm going to do the same thing here and here. Basically, what you're saying here, if it costs $30,094 to attend a private 4-year compared to $88.93 for a public 4-year, if it cost $100 for a private 4-year, how much would it cost for a public 4-year? So I'm going to find this X using the method. So how do you go from 30,094 to 100? Well, let's divide it and see. 30,094 divided by 100, move the decimal 2 places, is 300.94. So if I take 30,094 and I divide it by 3009.94, I will get 100. So I'm going to take 8893 and divide it by 300.94. Notice that number is 1. And if you do that, you will get 29.55. We don't need that anymore. So guess what I'm going to do to 3264 coming down to here? And if you guessed, I was going to divide it by 30094. Oops, that's going to, better get the white. You're correct. And I'm going to get 10.85. So it's a lot faster method of doing it. Well, as they say somewhere, that's all, folks. That's enough. But if you think it was long for you. Just imagine how long it took me to make this. I got to try to keep up with Julie and all her graphics. It's not easy.